if 2x plus 4 equals y and 3x plus 9 equals y, we're allowed to say stuff like this due to the transitive property of equality. 2x plus 4 equals y, and also 3x plus 9 equals y, so they're both equal to each other, and that's the transitive property of equality, ladies and germs. Oh, great, Camilla left us. And then the question is, find x. All right, well, subtract 2x, subtract 2x, cross u out, you get 4 equal to x plus 9, subtract 9, and x equals, stay it in the chat before I get to it,
-5.
Or Athena's just going to do it for me. -5 is correct. Good, Athena. Good. And good, all of you who wanted to say it. I am proud of each and every one of you. Let me go on the record for saying I'm proud of each and every one of you. Welcome back, Camilla. All right. Now, what are we doing today? We are continuing chapter 2. And we're going to talk about parallel lines, lines that never intersect. Now, here's SpongeBob, and SpongeBob is saying parallel lines have so much in common, it's a shame they will never meet. Now, that's funny, because parallel lines are two lines that will never intersect. Look at this pen and this X-Acto knife. If these were two lines that were to go on forever in both directions, they will never intersect. Now, if you have a master's degree or even a bachelor's degree or aspiring for a bachelor's degree in math, thank you, Santi. If you, some people might argue that parallel lines intersect in a place called infinity. Now, listen, you don't even know what that means. Your cute, adorable little brains can't grasp the concept of understanding what that could even potentially mean. But parallel lines, as long as we're concerned, don't intersect. Now, if I were to take a line and cut through any two lines, whether they're parallel or not, that line is called a transversal. Let's learn some vocabulary, baby. Parallel lines and transversals. See this line right here. See this line. See these lines here and here. These lines ain't even parallel. They're not. They're not. They're just two lines just broing down, just hanging out. These lines, or that one line that cuts through two other lines, is called a transversal. Okay? They don't have to be parallel. As long as one line cuts through two other lines, it's a transversal. If I were to go take this X-Acto knife and draw in my hand, just kidding. If I were to draw in my hand a line and a line, okay, I don't even know if they're parallel, and draw a line through it, I just created a transversal. Fun fact, my new tattoo idea. I'll never be able to get a job again, but, you know, I'm doing it. It looks like a political compass. Yep, I see it. Transversal. With transversals and lines, you have all these definitions that eventually will pop up on the screen, and there they are. When you take a line like this, and that straight line cuts through two other lines, you're going to create 8 angles, okay? 1, angle 2, angle 3, angle 4, 5, angle 6, angle 7, angle more, and that more is 8. Okay? The insides of the two lines that I cut through are called interior angles, because interior means inside. The outsides of the two lines that I have here are called exterior angles, because those are on the outside, and exterior mean outside. Hey gang, peep the picture. See the green? The green means interior, and the blue means exterior. Blue on the outside, green on the in. Consecutive interior angles are going to be angles that are on the same side of the transversal, but on the inside as well. So 4 and 5 are consecutive let me get my pen. Here's my neck. Respect it. Respect my neck. So there's 4 and 5. Those guys are on the inside of the 2 lines that are transversals cutting through, and they're on the same side of the transversal. Same thing with 3 and 6. Alternate interior angles are going to become a phrase that's very important, as are the next 2. Alternate interior angles are angles that are on the inside of your 2 lines, but on opposite sides of the transversal. So 4 and 6 would be examples of alternate interior angles. 4 and 6. Alternate means opposite or taking turns. Okay, so if they're interior and they're alternating, that means they're both on the inside because they're interior, but they're on opposite sides of the transversal. Similarly, 3 and 5 are also alternate interior angles. If you want to make an alternate exterior angle, just move that up there and move that down there. And those are angles on the outside of your 2 lines, but they're on opposite sides of the transversal as well. So 1 and 7 are alternate exterior angles. 2 and 8 are also alternate exterior angles. Corresponding angles are, and it's easier to see if I had parallel lines instead of these lines that are not. But if I were to say, look at that angle on the top left, look how 1 is on the top left of these 4 angles. Well, if I were to focus on the top left of the other 4 angles, 5 and 1 would correspond. Correspond means whatever I'm doing over here, something else is doing over there. Okay, it's the same behaviors, it's the same placement. So 1 and 5 are corresponding. 2 and 6 are corresponding. 3 and 7 are corresponding. 4 and 8 are corresponding. Okay, those are some names. Know them well. You should have learned them in grade 7, but you know, pandemic. So classify the relationship between each pair of angles as alternate interior, alternate exterior, corresponding or consecutive interior angles. We're going to do 1 in red. 1 is 1, 8 is 8. Please type out in the chat. Is it alternate interior, alternate exterior, corresponding or consecutive interior angles? And I'll just rewrite 1. It would be alt-ext. Because first off, they're on the outside. That's what gives it the exterior name. And since 1's on this side, so you can't see my fist, and 1's on the other side of the line, they alternate. And of course, there's an E there. Problem 2, which goes to the right and not below it. That's a dig at one of my parole officers. 2 talks about 2 and 4. And those happen to be what word? Too slow. Since 2 lives on the top right of this group of 4 angles, and 4 lives on the top right of that group of 4 angles, you have yourself corresponding. Corresponding means wherever they live on the one chunk of 4 angles, they're going to live in the same part on that chunk. 3 and 6. You're half right, Santi. You're half right. And this is the part that you are right. Interior. Good. See, they live on the inside. So the two lines here, this line and this line, those are my 2 lines. So imagine they're just like a wall and this line's cutting through the wall, or a fence. These guys are on the inside of the fence. And since they're on opposite sides, they are going to be alternate interior. I almost said the wrong thing, but I didn't. Last but not least, 6 and 7 are on the inside again. That was supposed to be purple. They're on the inside again. And since they're on the inside, that gives us interior. But is a corresponding interior? Consecutive interior. That's one that we will not use a lot. And of course, since I forgot it immediately, it's proof that we will not use it a lot. But consecutive means one after the other. Consecutive interior or cont-int or cons. Okay, just some vocabulary. I believe your IXL tomorrow is on this thing, just naming things, just making sure we can name them. Your assignment on Wednesday is to do a proof. Hey, gang, since we live in a 3D world, gang, let's talk about other things. First off, parallel lines are lines that live on the same plane and never intersect. So my hand, if I were to draw these two lines here, and these lines appear to never touch each other, even if the lines were to go on forever off of my hand, that's when they would be parallel. Skew lines are lines in real, like in 3D land, that will never intersect. So if I were to take this pen and my other stylus thing and touch these two things together, these intersect. They intersect. However, if I move this up, okay, we're now in 3D land, right? So these two lines, if they were lines that went on forever, they're not going to hit each other. Okay, one lives way the heck down here, one lives way up here. They're not going to intersect. Now, if I hold it this way, you might say, oh, that does intersect. Nuh-uh, not if I hold it this way, because that line is going towards you, and that line's going away from the side of you and stuff. That's what skew means. Parallel planes are two sheets of paper that will never intersect. So here's a plane, and here's a plane, and those planes will never intersect. Okay? They will never intersect. They will never, ever, ever intersect. Taylor Swift. They. Oh, let's talk about parallel lines once again. Corresponding angles. Remember I said corresponding, this word would be important. If you have parallel lines, and in this picture we do. Now, how do I know we have parallel lines? We will always denote parallel lines by putting little triangles right here on the lines that seem to be parallel. If I put a triangle here and put the same triangle there, that means that whatever this line's called and whatever that line is called will be parallel to each other. Okay, that's what parallel lines look like on a picture. So look at these, look at these, look at these. These are parallel lines. Look at angle 1 and look at angle 3. If I were to take a protractor, which I can, if I were to take a protractor and measure out how big angle 1 is and then go to angle 3, I can find the same exact measurement. Angle 1 and angle 3 are the same exact measurement because they are corresponding angles for parallel lines. Now, fun fact, remember the word vertical angle? Vertical angle means if I have this line intersecting that line, then opposite angles, okay, are going to be vertical. Just so happens that they're the same measure too. So angle 1 is equal to angle 3, and angle 3 is equal to angle 5, and angle 1 is also equal to 7, which means 1, 3, 5, and 7 are all equal to each other. 1, 3, 5, and 7 are all equal to each other. Thus and therefore, and concordantly, I could say, look at these corresponding angles, 8 and 6. Those are equal to each other. And since 8 and 2 are vertical, and since 4 and 6 are vertical, and 8 and 6 are equal, and 6 and 4 are equal, and 8 and 2 are equal, then 2 and 4 are equal. and all of them are equal. So when I have parallel lines and a transversal cutting through them, I'm going to have 6 or 8 angles. And 4 of them are going to be one measure, and the other 4 are going to be another measure, and those are the only 2 measures that you're going to have. Now, how big will they be? Easy. Angle 1 and 2 form what's called a linear pair. So does angle 3 and 4. So does angle 6 and 5. So does angle 8 and 7. So does angle 1 and 8. So does angle 2 and 7. So does angle 3 and 6. So does angle 4 and 5. What's a linear pair, you ask? 2 angles that add up to 180 degrees. So if 1 was 100 degrees, 2 would be 80 degrees because 1 and 2 add up to 180, which would mean 3 is also 100, which would mean 4 is also 80, which would mean 5 is also 100, which would mean 6 is 80, which would mean 7 is also 100, which would mean 8 is 80. So let's take a look at this John right here. This John says the measure of angle 5 is 72 degrees. Okay, and I want to find the measure of each angle. The measure of angle 1, the measure of angle 2, the measure of angle 3, and the measure of angle 4. The measure of angle 5, the measure of angle 6, that's supposed to be an M, the measure of angle 7, and the measure of angle 8. 8, I said. If 5 is 72 degrees, in the chat, give me something else that's 72 degrees. Six is 72 degrees. I don't agree with the 6, but I do agree, Miss Patel, with the 7 is 72 degrees. Because 5 and 7 are vertical. 5 and 7 are vertical, so let's check those off the list. Anything else that's 72 degrees, my guys? There's 2 more. Room temperature. Oh, that's good. Yes. 4 and 2. Very good. Basically, if you have parallel lines and you're given a measure of like one of those angles created by the transversal, if it looks like 5, it is 5. If it looks acute, then all of the other ones that are acute are going to be that exact measure. So here's the tricky part. What would all the other ones be? I have 4 other ones. What would they be? What measure? What angle measure? Like, what would 6 be? 180. See, 5 and 6 make 180. If 5 is already 72, then what's 6 going to be? Because 5 is already 70. Good, Santiago. So 180 minus 72, and Jill said 108. So 6 is 108. Where are you? 6 is 108. What else is 108? All of them. 108. 108. 108. Now that's not room temperature, right, Paul? Well, that was easy. Once you find the 1, all the ones that look like it are also that exact 1. The way you find the others is you say 180 minus that 1. So when we found out, when we were given 72, you said 5 and 7 and 4 and 2 are all going to be 72. What are the other 4 going to be? 180 minus 72, which is 108. Cool, Gucci gang. Let's talk about postulates. Somebody knocked on my door, which means my dog is going to go berserk in the background. Let's talk about theorems and postulates and stuff like that. If you watched the video on the Everyone Proofs video where it was about parallel lines. You probably saw me not want to use these words or these theorems, but they're there, and I might start using them more often if I think of it. Alternate interior angles theorem could also be the definition of alternate interior angles. Very good little pump. Now, if I were doing a proof, I could say that angle 1 is equal to angle 3 from the alternate interior angles theorem. I could also say definition of alternate interior angles. Same thing. Consecutive angles theorem, 4 and 3 add up to 180 degrees. 1 and 2 also add up to 180 degrees. And that's the consecutive interior angles theorem. I would probably say the definition of consecutive interior angles. And alternate exterior angles theorem say that 8 and 6 are equal and 5 and 7 are equal. That's what we get when we do all of these. I mean, we can find out that since 5 is equal to 7 and 7 is equal to 4 and 4 is equal to 2, I might as well just say 5 here is equal to 2 because of the alternate exterior angles theorem or the definition of alternate exterior angles. Perpendicular transversal theorem. If a plane or in a plane, if a line is perpendicular to one of two parallel lines, then it's perpendicular to the other line. That's just almost kind of common sense. I mean, if these two are parallel and these guys make perpendicular angles, then that guy is also going to make perpendicular angles. A theorem that we probably won't use that much, but you never know, and I guess we'll see. Perpendicular transversal theorem. Before we even do proofs, though, let's do a little bit of math, and we'll use the theorem that we can use. Now, looking at this picture, what we have is we have two parallel lines and a transversal cutting through it. I have y and x and 55 here. Okay. Y and x are related because they're on the inside. Now look at y and x. These are my parallel lines. Look at my parallel lines. Y and x are on the inside of it. They also alternate, which according to the alternate interior angles theorem, they're going to be equal. So what do I know in my brain? In my brain, and everything that I do in my brain, I'm going to make in purple. I know that whatever x is, y is going to be the same thing because of the alternate interior angles theorem. The 8. Now, 55 looks like an acute angle. X doesn't. So they're not going to be equal to each other. What I do know is that they form a linear pair. So those two guys add up to, which would make x equal to how many degrees? Yes, 125. I had to think about that for a second. Good. And since x is 125, that means
Y is 125.
Y is also 125. Very good. Y is 2. Very good. Again, if you're like, I don't understand. X and 55 are glued together, and when you glue them together, they create a straight line, which means they are a linear pair, which means they are supplementary, which means they add up to 180 degrees. So if this chunk is 155, the way I get 125, x is I do 180 minus 155, 180 minus 55, and that's what gave me 125. Since x and y are alternate interior angles of parallel lines, they're going to be equal to each other in measure, which means whatever x is, y is 2. And we said that over here, alternate interior angles theorem. I just need a one word for how I can set this up. How can I set a math equation up for these two? I mean, with these problems, they either add up to one. Okay, good. Good, Santiago. Now, what I have is, let's draw a picture again, even though Santiago said exactly what we need to do. We have here parallel lines. These guys don't live on the inside of them. They live on the outside. And just so happens that they live on the outside on opposite sides of the transversal. Okay, so this be Main Street, right? And this be on the good side of Main Street, and this be on the bad side of Main Street. And the rich kids live on the good side, and the not rich kids live on the bad side. But the thing is, what we've learned in history and lately, especially in the last couple of years of fighting the power, is it doesn't matter who lives on the poor side and who lives on the rich side. We're all equals in the eyes of God. So we're going to set them equal to each other. Can I get an amen, please? Somewhere in the chat?
Amen.
Thank you. Thank you. Thank you. Oh, in person and the chat. Oh, and several amens in the chat. Thank you. Now, what I have is these are alternate exterior angles because they're on the outside of my parallel line. So here's my parallel lines. So there you see them. They're on the outside of them. So one guy live over there and one guy live over there, right? And they're also on the opposite side of the transversal, alternate exterior angles. I mean, look at them. They look the same measure. So they're both obtuse. So they're going to be equal to each other. Again, with parallel lines, if they look the same, they are the same. Okay. Give me in 2 words my next step before I quick draw it out, or unmute yourself.
Add 10.
Add 10 is correct. And then either in the chat or unmute thyself, x is going to equal how many degrees? Oh, it is 114. Why was I about to write 124? And if you're like, I don't know, Mr. Perich, I need proof. I need proof. Well, okay. If these guys are going to be the same, then what's 114 minus 10? 104. Derp. So there's your proof right there. Camilla, I'm sorry, but that's incorrect. That's a really big number. And last time I checked, we're not putting my bank account numbers in here in the chat. Yes, I'm a quadrillionaire. Before we end the day, let's talk about proofs, dog. Let's talk about proofs. Allow me, please, to switch my camera. Yes, I said dog. I'm trying to communicate with my students. I'm trying to communicate effectively with my students by using words like bruh and dog and homie. Hey, homie, check this John out. Hey, homie, check this John out. I hope you're ready to check out some Johns. Can you see it? Nope. All right. I feel like if you click on the pin, you'll be able to see the entire screen, which you can. So we're good. Click on the pin so you can see the entire screen. We won't worry about these two today. We'll worry about that tamale. All right. What is we doing? We got ourselves a nice little proof. This is a fill-in-the-blank 2-column proof to introduce us to parallel line proofs. We're given information about parallel lines. Whoop-de-friggin' do. So let's do something about it. Speaking of whoop-de-freaking, let's do something about it. So I have, yeah, great. M and N are parallel, hence the triangles. L is a transversal, they connect. So before I even look at my proof that I'm here, I like to figure out what I know. Okay. 7 and 2 and 5 and 3 are all going to be equal to each other. Red's going to be equal to each other. I don't know why I felt necessary to write out the word red. 1, 8, 4, and 6 are going to be equal to each other. And I have to find a way to prove that angles 1 and 2 are supplementary, and also 3 and 4 are supplementary. So this is the proof that we just came up with. What was this? The consecutive interior angles theorem. We're proving that right now. A theorem that we will not use that often. We are being asked to prove it. So if I am writing out my statements and reasons, it's giving me a chunk from each side. Obviously, A is always going to be the given. So let's just write out the given. The given is M is parallel to N, and pretty looking L, so it doesn't look like the number 1, is a transversal. Angle 1 and angle 3 form a linear pair, so does angle 2 and so does angle 4. Now 1 and 3 are a linear pair because a line cuts through a straight line and creates so I guess we would use definition of linear pair. I mean, really, the reason why is a line cuts through a straight line, and if a line cuts through another line, each side of that line is going to create a linear pair, and that's really what a linear pair is. So we'll say definition of linear pair. Not a fan of it, but we'll do it. If two angles form a linear pair, they are supplementary. All right, so now it wants us to take the fact that these are linear pairs. Now they're supplementary. So what I have to do is I'm going to turn linear pair into supplementary. Linear pair, which would be angle 1 and angle 3, if they're supplementary, they add up to 180 degrees. That's what supplementary means. So how do I turn the phrase linear pair into supplementary? Add them up and make them equal 180. I'm going to do the same thing with angle 2 and angle 4. The measure of angle 2 plus the measure of angle 4 is 180. So I have that. And then all of a sudden it says angle 1 is congruent to angle 4, angle 2 is congruent to angle 3. Well, that has nothing to do with this. So I go to my picture. Angle 1 is congruent to angle 4. Oh, of course they are. They're alternate interior angles. And angle 2 is congruent to angle 3. Of course they are. They're alternate interior angles. So the reason behind that would be the alternate interior angles theorem. Now, again, you could write out, hold on, one thing at a time. Alternate interior angles theorem. You know, and if you wrote out here the definition of alternate interior angles, that would be perfectly acceptable too. Now, this is being recorded for somebody in the chat who said the phrase, do we write this? You know, I realize that I gave you the notes and it's not all of us are able to print out 100 and whatever pages of notes, but this is on you. So either you write it down or you watch it later and watch it again, or watch it again and make sure you understand, or you write it down and make sure you understand, however you understand. We are in strange times indeed. All right, so okay, so I'm going from 1 is congruent to 4 to the measure of 1 equals the measure of 4, and that's the definition of congruence. So I don't have to do anything there. But basically, we're making this guy look like E, and E looks like C. So what am I trying to prove? Well, I'm trying to prove angle 1 and angle 2 are supplementary, and angle 3 and angle 4 are supplementary. So I really want to add another line here, and I think I will, and you can't stop me. I'm going to make a G. You can't stop me. G, 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 G unit. And so my F is not going to be my last step. What I'm going to write down is my goal is to prove that 1 and 2 are supplementary. But before I do, I want to say that the measure of angle 1 plus the measure of angle 2 equal 180 degrees. How do I know that? 3 is 2. So if I were just to substitute 3 with 2, it's like me rewriting this top line here, and instead of 3, I have 2, and that would be the substitution property of equality. And if I'm going to say that the measure of angle 1 plus the measure of angle 2 is 180, then I can say that the measure of angle 3 plus the measure of angle 4 is 180. For the same reason. Because up here I have 2 plus 4 is 180. And then somebody swoops in and says, but 4 is, wait, but 2 is 3. So replace that 2 with 3. Got you. Now that they add up to 180, now I could say that the measure of angle 1 and the measure, just regular angle 1 and angle 2 are supplementary. And I can say that angle 3 and angle 4 are also supplementary. And that's the definition of supplementary angles. Definition of supplementary angles. Crisp. My job is to prove that guy right there. Okay, and let's just pretend we don't know a lot of the rules that we know. It would be very easy to do some mental gymnastics, which is the opposite of regular gymnastics. Don't make me crack a joke again about landing it. But this is what I'm going to do. I know that these two are parallel, so let me show that. Yay. If they're parallel, then these two are congruent. Why are these two congruent? Well, angle 1 is going to be congruent to angle 3 because they are, you could either put in the chat, I'll give you 3 options: alternate exterior angles, alternate interior angles, or corresponding interior angles. Consecutive interior angles. Which one? Alternate interior, alternate exterior, alternate interior angles is right. So I will say this guy equals that guy. And again, what I'm doing is given's my 1. This is my 2. I'm going to say what I know because of the given. Alternate interior angles theorem says that those two are equal to each other. My job is to prove that angle 1 and angle 2 are supplementary. All right, well, angle 1 and angle 2 aren't connected, but you know what is? Angle 2 and angle 3 are. So if I were to say 3, angle 2 and angle, I have to say measure. Let me put the M there. The measure of angle 2 plus the measure of angle 3 are going to be 180. And the reason for that is the definition of a linear pair. We saw that in the video where if you have 2 angles glued together, but when glued together, you can do that like little half circle because they form a straight line, then you have yourself a linear pair. Now, my job ultimately is to find out that 1 and 2 are supplementary. I have 2 and 3 showing that they're supplementary. Remember, 180 means that they're equal or that they're supplementary. Sorry. So I need to show 1 and 2 are, though, but I know that 1 and 3 are the same. So why don't I just turn 3 into 1? So step 4 is going to have me put 3 into 1. And I'm going to make a little note to myself that I'm actually, just so I can make, well, I don't need to. I'm good. Never mind. Take it back. If they are equal to 180, then angle 1 and angle 2 are sup. And that's because they're sup. This was substitution. My pen's dying. All right, so again, what I did is I needed to prove that 1 and 2 add up to 180. I know these guys were equal. I know those guys added up to 180. So if I can show that these guys add up to 180 and these guys are equal, I can replace that blue 3 with the blue 1. So I can, in my brain, think 1 and 2 are 180, which is what I'm supposed to get. It's all about taking what you're given, writing out the information of what you're given, and trying to find a way to connect it to the end. Okay? Okay. Let's turn that into a proof. Turn it into a proof. Watch out, boy, he'll chew you up. Turn it into a proof. It's a man-eater. Hall & Oates. What can you see? Do you see what I see? By the way, now that it's Christmas time, and I am going to say Christmas because the president says I can. I'm going to be doing a lot of Christmas carols. Do you see what I see? A post-it note. Shivering in the cold, let us bring him silver and gold. Let us bring him silver and gold. As usual, my first statement is going to be the given. And my given is G is parallel to H, and that's my given. If I bend that down, you can kind of see that I wrote out that angle 1 is congruent to angle 3. I feel like it's still fuzzy. You know what? I know why, because I don't have myself pinned. Ooh, I'm such a buffoon. All right, so fuzzy, fuzzy, not so fuzzy. So according to what I wrote up here, angle 2 is congruent to angle 3. And I know that angle 2 is congruent to angle 3 because the alternate interior angles theorem. So let me move up. Let me move you over and down a little bit. Angle 2, just kidding. Angle 1 is congruent to angle 3. And that's by definition, not by definition, that's the alternate interior angles theorem. Okay, if you said the definition of alternate interior angles, that would be perfectly fine. I'm just using what the book uses because the book, I burned my hand. I reached into a toaster oven and I burnt my hand getting my kids food. That's how much I love my kids. I do it for you guys too. That is unfortunate. Thank you, Santi. Step 3, according to the Post-it note, is the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And that's the definition of a linear pair. Did they like the food? Of course, dude, I made it. I'm a great cook. If I never went to college to be a teacher, I would have gone to culinary school. But in this case, I was probably just making them chicken nuggies, which they do enjoy. All right, so 4 says the measure of angle 2 plus the measure of angle 1 equals 180. What did I do there? I replaced 3 with 1 because 3 is 1. And so that would be when you replace things, that's the substitution property. And then last but not least, since 1 and 2 add up to 180 degrees, I can say that the angle 1 and angle 2 are supplementary. And that's the definition of supplementary angles. Breathe it in, boys and girls. Goes down smooth. I was given 2 angles are parallel, and I had to prove that 2 angles add up to 180. And the way I did that was I said, well, if these are parallel, then that guy and that guy are the same. These 2 add up to 180. So instead of 3, I could say 1 and 2 add up to 180, which means 1 and 2 are supplementary. That's how you do it in your head. And then on paper, you have to write that whole mess out. Pretty good, right? Pardon my language, but that John is stupid tough, yo. That John is stupid tough. Let's see if this John is equally as stupid tough. Another proof, so I don't need to have all that space for proofs. Given L is parallel to M, so let me draw my triangles. Prove 2 is congruent to 7. This is going to be the easiest proof I think we've ever done. And it might be 2 steps. There is a word for things like 2 and 7. Actually, 3 words. Can someone put in the chat what those 3 words are that can compare 2 and 7? Alternate exterior angles, Jill, is correct. So in the chat, what is always my first statement? The given. The given, the given, the given, the given. My given is L is parallel to M. Why the pretty L so it doesn't look like LLLM? Right, guys? Now, what are these guys? These guys are alternate interior angles, which means they are congruent. And according to this thing right here, according to that thing right there, this is not working at all. Why is it so difficult? According to that guy right there, the alternate interior angles theorem, if 2 parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. Okay, so this is a pair of parallel lines cut by a transversal, which means they're congruent, and that's according to the alternate net exterior angles theorem. So that was insanely easy. And maybe when I stole this problem from the internet, maybe what I was supposed to do was, like, you know, work for it a little bit. Maybe I was supposed to be like, well, 1 and 5 are the same thing, or 2 and 6 are the same thing, and 6 and 7 are vertical, so 2 and 7 are vertical. Great. But if we have the rules written right here, where it literally says they're alternate exterior angles theorem, it literally says, and let me present that screen again. It literally says it right there. Why don't I just use it? So I'm not going to overthink it. I'm not going to burn my brain. I'm just going to, like I did my hand, right, guys? Oh, it's fun. It's fun to make fun of yourself sometimes. But anyway, the alternate exterior angles theorem says if 2 parallel lines are cut by a transversal, then each pair of alternate exterior angles are congruent. And in this, what was I trying to find? If the alternate exterior angles are congruent. Well, are they parallel? Yes. Then the alternate exterior angles are congruent. That's it. Done.